All right, Chapter 6, Section 3, Scale Drawings and Models. It's the Google Maps round. Let's go. Okay, so vocabulary today. We have a scale drawing or a scale model. So a scale and a scale factor. They're all kind of related here. So a scale drawing or scale model represents an object that is too large or too, oh yeah, that's some good writing there, too small to be drawn or built. And a scale gives us a relationship between the measurements of the drawing model or measurements or of the real object. Most of the time these models and the scale, people think of like a 1/32 or a 1/16 scale model of an airplane. Or back in the day there were like model trains. There was O scale, there was HO scale, and those all meant something in what scale they are in comparison to the real thing. And then a scale factor would be the ratio. Oh man, this is just the need to be typos on this. Ratio of the length of the scale model or drawing or model to the corresponding length of a real object. So that scale factor is what I call the Google Maps factor. Because when it'll always have something like on a map that'll be down on the bottom right, that'll be like 1 mile is 1 inch, or 50 inches equals 1 mile. Anyways, moving on. All right, so a map has a scale of 1 inch equals 8 miles. Two towns are 3.25 inches apart. What is the actual distance between the two towns? So we can use what we had yesterday using proportions is how we're going to come up with this. So we're going to let x be the actual distance between the two towns, and then we're going to write and solve using a proportion. So the big thing here again is to make sure you get the same thing over the same thing. So in this case we went map over actual and map over actual. So the map is 1 inch. The actual is 8 inches. We know that the map says it's 3.25 inches apart, and the actual miles is x, because we don't know that's what they're asking for. So from there we can cross products, and this one's going to be easy because we just simplify. So we now know that 26 is going to be how many miles, because we have to say word problem, check the units. The actual distance is 26 miles. If you just put 26, it's not quite right. Okay, a map has a scale of 1 inch equals 8 miles. Two towns are 3.2 inches apart. What is the scale factor? So this is a little different. So we said scale factor back here was the ratio of the length of the scale drawing or model to the corresponding length of the real object. Okay, so to find the scale factor, we're going to write the ratio of 1 inch to 8 miles in simplest form. So 1 inch over 8 miles would be 1 inch over, oh man, they converted 8 miles to inches. So they did 8 miles, which is 5,280 feet, because that's what Remember the Titans says, times 12, or 8 times that many feet to that many inches. Wow. So the scale factor is 1 over 500,880. That is, each measurement on the map is 1 over this far, its actual measurement. Big numbers there, gotta love it. All right, on your mic, say go. All right, so a scale drawing has a house that is a scale inch of 1 inch per 4 feet. The height of the living room ceiling is 2.75 inches. Okay, so we're gonna do drawing over actual. Making sure I get this right. So the drawing is 1 inch over 4 feet is the actual, and that's 2.75 inches over an actual of, so they're looking for a height. So we'll do h. So we cross multiply, gives me 1h equals, let's punch that in my calculator, comes out to 11. So actual will be 11 feet. Oh, and all those things, of course, have to always pop up in the middle of my PowerPoint. Okay, so the scale factor, I had 1 inch over 4 feet. So we need to get it into the smallest one, so I need to convert 4 feet into inches. So 4 feet times 12 inches would give me the correct number. Yes, I work at a school. Surprise, surprise. So 4 times 12 would be 48 over 1, and those are both that would make them both in inches now. It would give me 1 over 48. Ta-da! Keeping going. A model car is 4 inches long, and the actual car is 12 feet long. What is the scale of the model? Okay, so write the ratio of the length of the model to the actual length of the car. So we're going to go length of model to the actual length of the car. Let's put A for actual. Then solve the proportion, which is the length of the model in 1 inch to the actual feet.
Video production class.
All right, 3 announcements and 2 bells later, we're back. Okay, so we have to do model over actual, then solve the proportion of the length of the model is 1 inch and the actual length is x feet. So what that would look like, so we're going to model over actual, 4 inches to actual of 12 feet. The model length is 1 inch, would be the actual length, or the actual length of the model. And we're looking for what is the scale. So we would cross products that, do that, x equals 4, divide both sides by 4, x equals 3. So the scale would be 1 inch equals 3 feet, which we got from the very beginning here, because this is 1 inch is how many feet. So that's where we get the second portion, because all they gave us was 4 inches and 12. What is the scale of the model? Well, we know that it's inches over feet, so with 1 inch is the actual length. All right, your turn, go. Okay, so a log cabin is 12 inches high, and the model is this long, and the actual is this long. What is the scale of the model? Okay, so we're going to do model over actual. So the model is 12 inches high, and the actual is 42 feet high. Well, if we want to have the actual model, so we need to know 1 inch on the model would be how far on the actual. That's where the A comes from. So cross products would give 12A equals 42 times 1, which would end up being 12A equals 42. Divide both sides by 12. A equals, I get 3.5. Yeah, 1 inch. So you can write this in any way you would like. You could do a scale of 1 over 3.5, which doesn't look really good. You could do 1 and then 2, 3.5 like this, or 1, 2, 3.5. All work. All right, patio. So Sheila is designing a patio that is 16 feet long and 14 feet wide. Make a scale drawing of the patio using the scale of 0.5 of an inch equals 4 feet. So first we need to measure the patio's length on the drawing and then let x be the length. So we know it's going to be 0.5 of an inch to 4. And we have x number of inches because we need to know that long, and we know the actual length is 16. So make sure the scale of the patio is this long to this long. Use the scale of this to this. So it doesn't actually matter which one of these two you use, I don't think. Okay, so we'd cross product, simplify, divide by 4. So on the drawing, the length is 2 inches long. So find the measure of the patio's width on the drawing. Let W represent the width. So now, first we did it. Okay, so we're going to have to do this twice. So do it once for 16 and once for 14. Put that in, times it across, simplify, divide by 4. There's my width. So on the drawing, the width is 1.75 or 1 3/4. So we put both those together, we can make a scale drawing on 1/4-inch grid paper. Since 2 inches is 8 squares and 1 3/4 is 7 squares, we can draw a rectangle that is 8 by 7 squares around, or squares. So it looks something like this. Okay, so we're going to have you do this again. You won't get all, well, I'll try to get this in your notes so you can draw it. Go. Okay, so we need to do 18 and 14 using this scale. So we're going to start with that. I'm going to try to do these up on the top here, or top corners. So if I go 0.5 of an inch over 4 feet equals, the actual is 18, and the model 18 is here, and the model is up here. So we'll cross multiply it, go 18 times 0.5 equals 4n. 18 times 0.5 would be 9. Because that's divided by 2 technically equals 4. So divide by 4. No, I don't normally like to do this, but I'm going to leave this at 9 over 4. Would be one side, or that'd be 2 1/4. And if we're using 1/4-inch grid paper, that means we'd use 9 of those squares. So if we do the same thing with 14, so we go 0.5, let's probably make it a 0.5 over 4 equals whatever distance over 14. So that's going to do 14 times 0.5 equals, cross producting, 4n, gives me 7 equals 4n, would give me, and divide by 4 would give me 7n, or 4 over 7n, so that would give me, so we have 9 squares and 7 squares. So then I draw that out, 9 squares, 7 squares, and when we put that into a drawing, it would look something like this. So this would be 9 squares long and 7 squares long.